Graphene is considered one of the most important breakthroughs in material science since its discovery. This wonder material was widely overhyped and still hasn't lived up to its potential. We can now see more concrete and realistic applications hitting the market, not those out-of-this-world promises like the space elevator. What if we could cut down carbon emissions from cement production by 20% and make cheaper and more powerful EV batteries using graphene? Is graphene finally starting to deliver on the promise? Let's see if we can come to a decision on this. I try my best to not get caught up in the hype, but I'm only human. At least that's the rumor. The original graphene hype got me super excited for the future of battery technology, computer processors, but not space elevators. I've always thought that one was just too out there. However, we're beginning to see this overhyped wonder material start to make its way into applications like building materials, energy storage, coatings, and electronics. Its potential benefits for those different applications is what sometimes leads to so much of the hype since its discovery. It's now 2022, and there are even more solid applications of graphene and research advancements happening right now that are worth exploring. Before we take a deep dive into these recent advancements, let's quickly revisit the basics of graphene. Graphene is a hexagonal honeycomb lattice made up of a single layer of carbon atoms. It's a physical form of carbon with a molecular bond length of 0.142 nanometers, and each atom is connected to 3 more around it by bonds that are very tight. Graphene essentially has only 2 dimensions, and if we stack several layers of it on top of each other, we can turn it into graphite. Research on graphene started in 1947 by physicist Philip R. Wallace, but it was only discovered by researchers from the University of Manchester in the United Kingdom in 2004 by Jaim and Novoslav. They used a sticky tape to peel flakes from a lump of graphite, separating the layers until they were only 1 atom thick. The discovery was so revolutionary that they were awarded the Nobel Prize in 2010. The wonder material, as graphene is often called, is one of the thinnest materials that we know of and the lightest compound ever discovered, weighing around 0.77 milligram per meter square. Graphene is also one of the strongest compounds, between 100 and 300 times stronger than steel, as well as one of the best heat and electricity conductors at room temperature. It has an electrical conductivity 70% higher than copper. Again, you can see why it's been overhyped. However, it hasn't been easy to scale up graphene production. Although it has all of the characteristics to be an excellent material in theory, manufacturing defect-free graphene is often too expensive. Its price can vary a lot based on the manufacturing conditions, and the methods for the mass production of this material haven't seen. It's something that often happens to discoveries in the lab. Bringing it to market and producing it cheaply at scale can be extremely difficult. Even though the best physical properties of graphene can be achieved using the peeling method proposed by Jaim and Novoslav, it isn't the most effective and feasible way to produce tons of graphene. Chemical vapor deposition, CVD, is one of the main processes utilized to produce graphene. This procedure consists of synthesizing graphene on a substrate, often copper foil, but it's still a challenge to produce long sheets of this material at scale. However, one example of a partnership trying to push this boundary is the joint venture formed between the Chinese company, Hangzhou Cable Co., and the University of New South Wales that's trying to manufacture graphene power cables. The cables could reduce electricity leakages, lowering electricity costs and carbon emissions while improving the quality of grid transmission. The technology developed by the university could save about 275 terawatt-hour in theory. While that's very interesting, we haven't seen the innovation come out of the lab yet. Even so, graphene isn't just a list of unkept promises. There are a lot of places it's creeping into production today, and most of it is under the radar. In short, graphene has applications in places you might not expect. Because graphene is strong, light, and an outstanding heat conductor, it can be a great material for producing heat sinks or heat dissipation films. Huawei's latest smartphones, for example, have adopted graphene-based thermal films, and the British company Graphene Lighting is producing LED lights using graphene as a thermal dissipation solution. Graphene can also be used for protective coatings with superior chemical, moisture, corrosion, and fire resistance. The Chinese company The Sixth Element produces several graphene products, including a graphene zinc anti-corrosion primer that's suitable for offshore wind turbine towers and has a competitive price compared with zinc epoxy primers. The big benefit is how it can improve the anti-corrosion properties of paint by significantly reducing the amount of zinc powder and extending the lifespan of offshore wind turbines. However, where I think graphene applications get super interesting is in the building sector. The Australian-based company First Graphene has its sights on the cement and concrete industry. Cement accounts for between 8–10% of CO2 emissions, which explains why it was a target for CO2 reduction at 26 Colombian pesos. 40 of the world's biggest cement and concrete companies have banded together to speed up the transition to greener concrete by pledging to reduce CO2 emissions by 25% by 2030. In the cement production roadmap, the main focus of carbon emissions is associated with the rotary cement kilns, where the raw meal is burnt and calcined into something called clinker, which is used as the binder of cement. In this process, huge amounts of electricity are spent, and for every ton of clinker produced, we're talking about 800 to 900 kilograms of CO2 per ton. So, first, graphene is tackling the final grinding step, where graphene can improve the efficiency of the cement grinding process. Graphene reduces the surface energy forces that cause agglomeration, or clumping, of the newly fractured cement particles. To do this, they produce graphene based on electrochemical exfoliation, in which graphene is obtained from graphite when a voltage is applied to it. The voltage makes ionic species intercalate, basically to inject themselves into the carbon layers where they produce gases that expand and exfoliate individual graphene sheets. Instead of using tape to rip off layers of graphene, you're using electricity to shed off layers of graphene. It basically sheds layers of graphene one at a time. They can produce graphene platelets with sizes between 5 and 70 microns, which can then be easily dispersed into materials like concrete, adding just a small amount of their graphene product, as low as 0.01% of the total concrete mix, to concrete improves tensile and compressive strength, also reducing weight and the chances of cracking. The company explained how these improvements happen. Graphene is a nanoscale reinforcement, like steel reinforcement bar, but at the atomic level. The graphene can permeate the cement gel and stop cracks from developing on the nanoscale. According to a case study made by the company, when tested to international standard methods, product increases the compressive strength of concrete by 34% and tensile strength by 27%. On top of that, it extends the life of reinforced concrete structures because it avoids corrosion and also reduces clinker by 20%. This is where that CO2 reduction comes into play because of how it helps with clinker. CO2 emissions can be reduced by 18% minus 20%. The company has been diversifying applications in several other sectors, including automotive, aerospace, boat and wind turbine blade manufacturing, and a lot more. First Graphene CEO Michael Bell said, "A number of these products are already in commercial production, including graphene-enhanced swimming pools, footwear, fire-retardant paints, and wear liners for mining applications." First Graphene also secured a UK patent for coating silicon anode particles with graphene for energy storage applications. These silicon anodes have the potential to achieve energy densities 10x higher than graphite anodes, which currently sits at 400 mA per gram. Although this technology is still at the early stage of development, the big problem of these anodes is that they degrade easily, have low intrinsic electrical conductivity, and have a slow diffusion rate of lithium within the electrode. But coating the anode with graphene could increase conductivity and reduce the degradation issue. First Graphene isn't alone here. Global Graphene Group is another company that's been exploring this market. Similar to First Graphene, they manufacture several types of powders and pastes for different applications. Their technology can also be applied to energy storage to reduce problems with dendrites in the lithium metal anode of solid-state, lithium-sulfur, and lithium-air batteries, as well as helping to reduce fire risk. It enables the use of advanced cathode materials such as NMC 811 or sulfur, which opens up room for an energy density boost, sometimes over 350 watt-hour per kilogram for lithium-sulfur battery, and keeps the cost lower than $100 per kilowatt-hour. The Global Graphene Group is also focusing on silicon anodes with their subsidiary Angstrom Energy. According to the company, the flexibility and mechanical strength of single-layer graphene wrapped around silicon nanoparticles helps cushion the volume of the silicon during the charging and discharging process. So those are some good examples of where graphene production stands today and where companies are starting to pilot its applications. But what about tomorrow? You don't have to look very far to see where the research is taking graphene. An interesting study made by researchers from the Skolkovo Institute of Science and Technology presented the first graphene synthesis approach that uses carbon monoxide as the carbon source. In addition to producing graphene at high quality, the technique proposed in the paper achieved low costs and great production speed. Skoltech professor Albert Nazabulin, who's leading the research, said, "The beauty of carbon monoxide is in its exclusively catalytic decomposition, which allowed us to implement self-limiting synthesis of large crystals of single-layer graphene even at ambient pressure. Their strategy takes advantage of the so-called self-limiting principle. When carbon monoxide molecules get close to the copper substrate at high temperatures, they tend to split into carbon and oxygen atoms. This propensity fades when the first layer of crystalline carbon is produced and separates the gas from the substrate. According to Skoltech intern Artem Grabenko, the system offers several advantages. The resulting graphene is pure, grows faster, and forms better crystals. Moreover, this tweak prevents accidents with hydrogen and other explosive gases by eliminating them from the process altogether. When it comes to costs, Grabenko pointed out, once you drop the high-end hardware for generating ultra-high vacuum, you can actually assemble our garage solution for no more than $1,000. Graphene has the potential to improve materials performance and also help to chart the path toward a low-carbon future. The graphene market has been hot around the globe and is projected to grow from $388.8 million in 2021 to over $4.6 billion in 2028 at a rate of 39.8%. However, scaling up production and standardizing the quality of graphene are still challenging, which leads to cost as a big problem. Although graphene prices decreased from tens of thousands of dollars for a small piece in 2010 to about $100 per gram currently, it's still an expensive material. Although we can see exciting products and applications hitting the market now and in the very near future, it looks like we're still waiting for the bigger promises of graphene. However, with companies like First Graphene and Global Graphene Group starting to push and perfect the manufacturing process, it's looking like we're closer to graphene's promise than ever before. We still have to wait though, especially for that space elevator. If you enjoy our video, don't forget to subscribe our channel and comment down below what kind of technology you want to see in the next video.